and take it away.
Awesome, thank you. Okay, good morning, everyone. My name is Lloan. I'm going to try to give you guys a walkthrough of Project 3. I understand that a lot of us may have done this project a bit different, but I'm going to cover the basics of the rubric. So if you guys have your rubric up, you guys can see that the very basics are these. You have to make sure that the player can not move off the screen, make sure that the vehicles, well, in this case, the bugs can cross the screen, and then these other three. We're going to try to cover these as best as possible. We only have an hour, so we'll see what we can do, okay? So let me open up the project. So you can see I have a couple of versions here, one that's done and then one that's undocumented. I removed all the comments. And when you first open this project, there is nothing. So you guys have all these errors here, okay? So you guys can see that it's giving you an error telling you that all enemies are not defined. So if you just want to get started with this, we can just create this in the apps.js file. So that's one of the things we're going to do first. But before we do that, I want to make sure that you guys understand that these two other files are inside the project, engine.js and resources.js. That's just part of the project that's already built for you guys. So there's no reason for you guys to have to worry about touching any of that. The only reason you would modify these files is if you're trying to add a different character or you're going to customize the game any further. But apart from that, if you're going to stick to the very basics, you should be fine with this. This just deals with loading all the images and caching them so that when players refresh your game, it doesn't take as long as the first time. Okay, so we can go ahead and get started. Right before we do, let me show you what it will look like by the time we're done. So you guys can see that I have two variables at the top. Those deal with debugging, which I'll show you guys what that is, and I'll make sure to include that code for you guys if you guys want to test it out later. And then the status of the game, so that we know when it's true, the game's working. When it's false, the game has ended. And then we have our enemy object and the methods for the enemy. We have the player object and the methods for the player. And then the event listener for key input and everything else, okay? Okay, so one thing I do when I do these projects is I obviously read the comments, but then I get rid of them so I can start from scratch. Let me, okay. I'm going to start somewhere here at the bottom, okay? So we're going to go ahead and we're going to declare that all enemies variable. If I can type properly, I've had no coffee, guys, so bear with me. Okay, so one thing that you guys are going to want to do as well is because you need 3 bugs, you're going to make an array of the positions to the bug, and we're going to iterate through that, and that's how we're going to populate them. So let's go ahead and do this so we can see what error pops up. Okay. So player is not defined. We're going to go through the errors and see what happens. Because one of the really important things when doing any of these projects is your debugging skills. Okay, so now you can see that it's asking for a method for player. Okay. So let's go ahead and just get it out of the way. We're going to use the enemy object as an example to create the player one. Actually, I could have been lazy, just copy this over and just rename it, but oh well. Okay. So we can see here that for the enemy, they've declared the sprite, and they're using the URL to this image. We can go ahead and do the same thing. We can just copy it from down here for the character, okay? Now, again, if you guys are gonna change it, let's say we use a girl, you guys can just add it in here as well. Okay, so I'm gonna go ahead and use this one. And then we're gonna go ahead and add the update and render methods to the player. And same thing, just copy this. And the update method. I'm gonna get lazy and just copy that one. Okay, let's see what happens. And we'll just go through the errors as they come in. Okay, player update, same thing. We have it right here. We have the function, but I forgot to define it here. Okay, so new player, that's what we call the function here. Okay, so you guys can see that now we have a canvas on here, okay? But we have no player, we have no bugs, we have nothing. Okay. So now what we're going to do is here, we want to make sure that we define the X and Y for both the enemies and the characters. So that when we spawn them on the screen, we actually get something on the screen. So we have our player object here. Let's go ahead and add parameters to that. We're going to add the X and Y, and we're going to use them here. Now, I know some of you guys probably did this with classes. It has kind of the same principle when doing them with classes, but I'll give you guys an example after we're done doing this way. And you guys can take a look at that one. I personally did it with classes, but I wanted to go off what the project provided you guys. Let's do the same for enemies. And then the reason we're doing this is because when we create, like, for example, our new player here, we want to pass in where he's going to spawn. So let's put this guy. And then I know some of you guys are going to want to change the image. So let's try using the girl. Okay. So if we take a look at the player function right here, I keep switching between function and object, guys. I'm sorry. So we see the sprite variable here, and we want to do it dynamically, right? We want to pass it when we create the item here. So let's make sure we pass it as a parameter. Call it something like sprite. And we'll pass it in here. Okay. So you can see our little character has loaded on the screen. Now, let's say we change this back to, where's the original one? This one. And you see that the character switches. Okay, so that's how this works. So we pass the parameters are being taken here, and we're using them here. Okay. Now let's get, we don't need to do that for the bugs, unless you're gonna have random bugs using different sprites. But again, for the most basic, you can have the sprite being static. They're all the same bug. The only thing that's really important is where they start on the X axis and Y. And as a reminder, for the canvas, 0, 0 starts up here, top left. So let's create an array that holds the positions for our bugs on the y-axis. So I call this enemy positions. Now, I'm assuming one of the questions you guys have is why these positions, right? So the way I got these positions is through a lot of playing around with this, because you have to position these guys within these little boxes, okay? So you'll see that when I get these bugs going, you'll see them actually land in these boxes instead of like in the middle of them or something, okay? Now, we also want to have the all enemies right here, because that's where the engine is taking all the enemies from, okay? So what we're going to do, I don't know if you guys have covered ES6 JavaScript, but we're going to use something called the map function. Basically what that does is it creates a new array while iterating through all the items within the array that you're giving it here, and it'll apply any function that you give it here to each item, okay? Okay, so what I'm doing here is, this is what I'm calling every item inside the enemy position array. So each one of these will be referenced to as y, and the index is given to me through this function, okay? I'm going to use it here to return a new enemy. Same thing I did here with player is what I'm going to do here, okay? So this would be your x, right? So what we're going to do is we're going to use the index to create a random place on the canvas, okay? And we're going to pass it in the y from the any position array. Now this part here will get a bit tricky, but you guys can do it any way you want. You can set up your own random number or whatever. On my end, my goal was to make sure that the enemies spawned off the canvas. So say it'll be a negative number. So something like negative 100, negative 200. So you guys can have the illusion that the enemy's traveling from somewhere, I don't know from where, and it's coming into the canvas, okay? So what I did on my end is I had a number like negative 200, and I multiplied that times the index plus 1, okay? Now, why did I do index plus 1? Is because I know I'm going to have an index of 0 at some point here, and that would give me 0, and that would be kind of useless. So I added 1 so that I always start at 1, okay? So this will give me something like negative 200 times, let's say we start with 0 plus 1, so it'll multiply that. And then my first enemy will start at negative 200, my next enemy will start at negative 400, and so on. If I got my math right, again, no coffee, so there you go. So let's see what happens when we do this, okay? Let's save it. Okay, nothing, that's good. Now let's look at the render function, okay? Player, let me fold these. Okay. 1 second. One second, guys. So let's start, let's see, let's go with the, let me see here. So I don't know how many of you guys are going to use the update function. I didn't use it for the player, but what that function does is anything. Well, I guess I didn't explain the game loop, but the game loop is essentially a loop that iterates over and over until you tell it to stop. So every time the loop iterates, it'll run this function and anything you put into the player update function. Okay, so you can update anything like the status of the game. You can update how many lives are left, anything you want. But that's all depending on how you guys designed your own game. So one other thing I did, and I'm not sure how to explain this, is if you look at these images for the enemies, it opens Photoshop, okay. Yeah, that doesn't help at all. You guys can see that it has space at the top and space at the bottom. So these images, you can see that they're 101 by 171. So the width of the image is 101 and the height is 171. So we want to keep that in mind because we want the width and height of the bug and the character. And the reason why is because later on we're going to create a little function for collision, so that when the player runs into the enemy, we'll send him back to where he started. Okay. So what we're going to do is, I already went ahead and got my height and the width for the enemy. So that means that my height is 65 pixels. My width will be 95. And then as you guys saw in the beginning, I had these two variables at the top. This first one you guys might not use, but I'll show you guys what it's for, so you guys can see the collision in action. And then I'll go ahead and act like I'm not doing this part, okay? That I will explain if we get time. Well, actually, we're doing pretty good on time. I can see Brenda just smiling. Okay. Okay, we don't need this one. Just looking at my notes, guys. And then let's do the same for our player. As I said, I already got these dimensions for these guys, so. Yeah. So let's see, where's the input? Okay. So when we start moving the player, it's going to ask us to use this function, handle input. So let's go ahead and set that up so we can get him moving already. Okay. This is going to pass us the direction that the player is going to move in. Right now, if I try to move, it doesn't do anything other than give me an error that there's a function that it's missing. Okay. So we're going to take a parameter here, which is going to be the direction. And that's how we're going to tell our player to move. Okay. So let's start with type. The direction is left. Do something. Else if it's right, do something. And you guys can see the pattern. You guys can do this any other way you guys want. This is just to illustrate a point, because there are better ways to do this. Okay, so when the character moves left, we're obviously going to make him go to the left on the x-axis. Right, we're going to make him go right on the x-axis. So we're going to modify his x-coordinate, okay? And we're going to have him move this many. Okay, so you guys will notice this right here. Okay, I don't know if you guys have covered it yet, but that's basically taken away 100 from whatever the value this currently is. Okay, it's the same as saying same thing. Okay. Now for these two, we're going to modify the y. We're going to do okay. Okay, so I can move my character now. You guys can see I go off the map. And then you guys can also see that I stay within the blocks. That's because this is not a random number. It's actually based on the width and height of this game. And how would you get to that? When you guys are working on it by yourself, you would play with the numbers and see how far it moves. So let's say I had originally put 50 in there. You see that it's kind of weird. You guys would have to play around with it until you guys got the correct movement parameters. Let's see. 100. I should have eaten cereal or something. Well, let me see what else we can do. We should probably get the bugs rendered. Let's see what we're missing here. So just so you guys know, I have, well, I had, I had something there, but we'll see it in a second. I'm trying to see. Just so you guys know, so it's not such an awkward silence. I have the other project open on the other monitor I have. I'm not magically just taking this out of my head. Okay. So what I'm trying to do right now, I'm trying to see where my little bugs are at. Let's do this. We're gonna do some debugging. Okay, perfect. So we know where they're at. So our enemies are being rendered. The reason why they're not showing up is because they're lazy. They're not moving. So we need to make sure that we get them moving. So let's do this. Let's get them moving. So right now they're off the canvas, okay? Because that's how we program them. One of them's like -200, one of them's -400, and then -600. So they're way off the map. So here we're gonna get them moving. So every time the loop iterates, it'll move them this much. Okay? So yeah, I think you guys saw that. Now, what this delta does, this parameter passed in through the engine, it kind of normalizes the animation. You guys can see the little enemies moving along the stream. Okay. Now again, if I removed delta there, they just run through it. Okay. So let's leave that there. And as it is right now, this guy's Superman. He can touch him, so he doesn't get him. Okay. Okay. So looking at the rubric, we have the vehicles can cross the screen. Okay, that's one off the list. Let's go ahead and actually. Okay, so you can cross the screen. So let's tackle player cannot move off the screen. So there's a lot of different ways we could do this. We're going to tackle the player not going off the screen. As you can see right now, he goes off the screen. We're going to put that in the handle input function, just so our thing doesn't get too big, but we could have done it here or any other custom function you wanted to do. But we're going to try to keep everything all together. So let's see. Where is the... So here's what we're going to do. So we're going to define a couple of variables right now. And I'll show you guys where I got these from. Okay. So I got the horizontal 101 and vertical 83 from here. You guys can see that each column is 101 and each row is 83 pixels. And again, there are many different ways you guys could do this, but this is the way I use just for the purpose of this. So you guys can see that you guys don't touch this, but you guys do get information off of it. So for example, each column is 101 pixels and each row is 83. Okay. And we're going to use this here. We're also going to use the player's height and width. And I'll explain why. So whenever the character, I guess the player tries to move left, we're going to do a couple of things. We're going to check if the future position of the player. So we're going to check if the future position of the player is within the bounds of the game. Okay, so we're going to do that by getting the current X of the character and taking away the width, not the width, the size of the the column, and we're going to make sure that it's greater than or equal to 0. So that means it'll be within the bounds on this side. Okay. Now what that means is we're going to use the horizontal for the movement from left to right. Okay. And we're going to use the vertical size, the 83 pixels, for going up and down. Okay. That'll keep our little character within the boxes. Well, let's see if I broke it yet. Okay. So it's within the box. And I can't move to the left anymore. Okay. So you guys can see that we got that working so far. Now we can do the right side. So same thing, we're going to check if adding 101 pixels to the current X position of the character will get him off the screen. Okay, so let me explain this one. CTX, I believe it should be accessible right now. Yeah, great. So that is the canvas, the context of the canvas. So if you do this on your guys' end, you guys can see you have a canvas object, okay? And it has the width and height. So that's what I'm using here. I'm using the width of the canvas because I'm checking that it's less than the width of the canvas. So if it goes over, he's not going anywhere. Okay. And we'll also be able to use the height of the canvas below. So you can see that he can't move. So he's within the boundaries now. I can go off here, but not to the right. Okay. And we'll do the same to the down and the up. Oh. Now, for this one, it's a bit weird because again, we start at 0 up here, 0, 0, and we go all the way down. But as I pointed out, these images have spaces and everything. So the math for it is a bit weird, unless you guys can find a better method. But on my end, I removed 200 from the height when doing the comparison. Otherwise, my little character was moving off the screen to about right here because of this extra space here. Okay. Mm-hmm. So let's check if he goes off the screen. So up and then down. So he stops there. So let's see, just for the sake of illustrating what happens. You guys can see he's stuck there now. So 200 has him end exactly where we want him to end. Right there. Right above the little patch right there. Now we're going to do up. So again, we're going to compare the y coordinate for the character and make sure that when we move him, he doesn't end up outside. Now, let me remove this and show you guys what happens. You can see it's not going anywhere right now. But when I move him up, it'll be a negative number. So that's why this is not letting me do it. Oh. Player. Okay, now it works fine. And again, these are all little things that you would have arrived to as you're playing around with the the numbers here, you would have figured that you end up right here, and then you'll start taking away from the height and so on. Or you would have figured out a different way. Okay, so we can go out there, we can go out here, up. Okay, so we're good. So we covered another one. This one, player cannot move off screen. So that's 2. Okay, let's go back. Now that we've done this, let's go back to the enemy real quick. And let's make sure that whenever they go off the screen, we bring them right back. Otherwise, the character just has to wait till they move, and then he can win the game. So we're going to check for the X of the enemy. The cool thing is, since we have objects, we have different instances of the enemy. We only write this function once, and then they all know what to do, no matter where they're at. Okay. So what I'm saying here is, if the X position of the enemy is greater than the canvas width plus the width of the bug, we're going to want to reset the bug off the canvas again on the left side. Okay, so we're going to need to give it a negative number. Okay, so let's do, we can take this same idea and apply it up here, but this time we'll give it a random number. Okay. So this right here gives us a random number between 1 to 4. Okay? We're using this to round it. Now we want it to be negative, so we have the same thing here that we basically took from here. Okay? So whenever the bug goes out the canvas, it'll go right back. So let's see if that happens. Else. Otherwise, if the top's not true and they're within the canvas, just keep moving them. Okay. So let's see what happens. Okay. Oh, there you go. Started from here. That's weird. Cool. So it works. So now we have the bugs going forever and ever.
Yeah. That was good.
Let's see. So now let's look at the rubric one more time. Collision. Okay. So there are a couple of ways to do collision. It's a bit tricky. But the way that I did it was we add collision to the enemies, to the little bugs, so they detect whenever they come in contact with the player. So I'm going to add something real quick. You guys don't have to worry about this part. This is for the debugging. I want to see if I can show you guys something real quick. Collision, okay. 1 second. Close your eyes. Okay. And set this. And the render. Okay. So this is for debugging purposes. So basically what I'm trying to illustrate here is when these little bugs are moving, you have your X and your Y. So you guys can see how the X is incrementing, right? But you guys can see that the Y is constant. So that's the Y that it's on right now. So 230, 140, 55. Those should be the numbers we pass it in here. So 55, 140, and 230. Okay, good. Thought they were wrong for a second. The next thing is that box around it. That's the box we want to target. That's our bounding box or whatever we want to call it. But whenever our player goes next to it, we want to make sure that he goes back. Okay? So when I touch it, you see how my character goes back? See? Okay. So what is doing that is the following. Come on. Okay. So let me hide the debugging ones real quick. So when I first did this this project, I spent quite a bit of time trying to come up with my own way to do the collision. But then I found this this post on Stack Overflow, and I referenced it in my own project that I can show you guys later. But basically, it does the following. It'll get the absolute value of, well, actually, let me explain what these are before I confuse you guys anymore. So we have all these P variables: player X, player Y, player width, and player height. Okay, when you explain this, it makes a bit more sense. But so we have these from the player, and these are for the enemy. So the enemy's X and Y coordinate, the enemy's width, and enemy's height. Okay. Now, if you guys take a second, this does make sense. So we get the player's X and the enemy's X. So we take the enemy's X from the player's X, and we get the absolute value. We multiply that by 2, and we check if that's less than the player's width plus the enemy's width. Basically, what that's checking for is to make sure it's within proximity. Okay. So if it's close to the enemy, it'll let you know, and that's how we use it in our game. We make sure that both of these return true, and if they both return true, that the player is within proximity vertically and horizontally, and that means that there is a collision. Okay. Let's delete these comments here. No, not that. Okay. Now I know this will probably need more explanation, but when I give you guys the comments, you guys can take a look at the comments as well, and then we can take questions. So collision will return a true or false of a Boolean, and that's what we're going to use for the collision. And as I said, we're going to add that to the enemy. Okay, so we added it here. Let's see. So collision. So we use the function and we pass in all the required parameters. We pass in the player X, Y, the width, and the height, and then the information for this current enemy as well. So the enemy's X, Y, width, and height. Okay. And what this is saying is, if there is a collision, set the collision for this to be true. And that is a parameter here. We pass to the enemy, and we'll also add it to the. We don't need it for the player. We should be fine. That lets us know that there's a collision, and then we check if the player is true, because there are instances where maybe the variable's not accessible or whatever the case may be. But you always want to check that the variable is accessible. We're going to reset the player position. So that's essentially what this does. Okay. So if the collision is true, if there is a collision, it'll reset the character. Otherwise, the collision is false. And that's all that does. Again, is there a better way to do that? Probably. Okay. But this is pretty straightforward once you understand what this is doing. Okay. So let's turn off those little boxes. Okay. So now if we touch one of these, we're sent back. Oh, gotta get away. Okay. So we can see that they happen right on time. One of these items on the rubric says vehicle player collisions happen logically, not too early or too late. You can see that it actually touches the player. So it doesn't happen too early or too late. It doesn't move him back. See, so that's great. So we cover that. And the reason why is because we set the width and the height depending on the image that we were provided. Okay. Okay, vehicle player collision resets the game. So we're not resetting the game, we're resetting the character's position. So the character goes back. So that does cover that. And lastly, we have something happens when the player wins. Okay, so that is a two-step process because we have to make sure that we set when the player actually wins. So that means the character wins, right? When he gets to that part. And we need to trigger something to happen when that happens. Okay. Now, whatever you guys do for the win part is up to you guys. You guys can do a modal or anything, but what we're going to do is we're going to set the trigger, and we're going to probably have it log something to the console. Okay, and we can do that in the update function. Let's do that there. We're going to use this variable, okay, the game. So we're going to check if the game is currently running, so it's currently true, and the player y coordinate is less than 40. So from like right here and up, he made it to the river, to the lake. Not really sure what that is. Maybe it's the ocean. The player made it there. Now we set our game to equal false, and then we trigger whatever we want. Okay, so let's make a one function. The player one. Let's remove this. Two. Let's trigger a message. Let's see if that happens. So you guys can see the message here. Let's go a step further. We have a couple minutes. Let's add a if I can type, come on. You guys can see I for some reason I declared it. Let's reset it. We're going to want to get rid of all the enemies. And we know that the engine looks at the all enemies array. So what we can do is we can just set all enemies to a blank array. And that'll make the illusion that we've reset the game. Okay. So let's go to, we can include it here, I guess. Yeah. Assignment to constant variable, of course. Where is it? Right here. I was trying to change a constant. That's a no-no. We don't do that. Okay. So I made it I use let. Perfect. Okay. So let's try that again. So we have the bugs. As soon as I make it to the water, they're gone. Okay. Now from there, you guys can do anything. You guys can stop the listening to the input for the player. You can make a little pop-up appear. Anything you guys want, but as it is right now, you guys have something happening when the player wins. Okay. So you guys don't need the debugging part, and you guys don't need the bounding box, those little red boxes that were appearing. That was just for the purpose of us seeing where the collision would have to happen. Okay. And we can get rid of this. Let me save. Okay, good. I think that covers everything. Yeah, so something happens when the player wins. At this point, something happens when player wins is more a matter of how complex you want it to get. But everything's there, so I guess we can take questions now.
Can I just say that was really, really good? Like really, really good. If anyone has a question, feel free to unmute yourself, or you can leave a question in chat. Yeah, everybody seconds that. Really good.
Oh, thank you guys.
Yeah.
I'm not really much of a social person, so.
Oh man, you killed it today. I tell you, really good.
And certain things, like this was supposed to take 20 hours, right? He got his in one.
Right, so I said I would show you guys what I did for mine real quick. Just so you guys can see, you guys can build anything really with what you've learned up to this point. So mine, what it was a, I took everything that we learned in there, and you can walk around, same thing. You can also attack enemies, and you can pick up items. So
1 of 10 around the world, each constructed a minimum fallout.
Can you repeat that?
That might have accidentally come over the microphone.
Oh. But yeah, so again, you guys can do whatever you want for this game, but the most basic parts we covered, and that should get you through the project. And then if you guys in the future want to come back, you know that with what you've learned so far, you guys can build absolutely anything.
Yeah, I felt like the next logical step in this arcade game would be to level it and make the bugs go faster across the screen, or give more or something.
Yeah, so there's a lot of things you can do to what you have already. You can add things from lives to points, a score, etc. Yeah, with what you have, there's a lot you can do.
Can I just add too? I mean, this is mind-blowing. I just want to encourage you guys that, like what was mentioned too, follow the rubric, get it submitted. You guys can always fancy it up later. I want you guys to really get that down and agree, and that means getting all your projects submitted. So definitely, I love that you guys are kind of thinking about where to take this kind of basics and fancy it up later to put in your portfolio. But oh my gosh, please graduate. I know you guys can do it. And this is, you know, having this walkthrough today just really shows just, you know, it's, you guys can do it. Really, you can. So amazing. Anyway, we're going to open the floor open for last questions, okay? If not, we're going to let you wrap up a few minutes early to prepare. We have P4 coming on at 9:30 Pacific time, 12:30 Eastern time, and I hope you guys will join us. You've seen how great that this walkthrough is. So, and yes, it's being recorded, and I'm going to let you guys. Here are the links to the FEND scholarship page. We'll post the walkthrough, and then also the tech webinars page. I'll post it there too, okay? All right. Any questions, last questions? All right, round of applause. Thank you. Great
Awesome,
job.
thank you.
Thank you very much.